Hello everyone and good afternoon. Dear authors and invited guests, welcome to Technical Session 8C. Myself, Adesh Bazare, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Now, just before we start the session, I would like to introduce you all to the chair for this session, Dr. Ashish Patel. Sir is an associate professor at Parul Institute of Pharmacy, Parul University, Gujarat. With a robust background in organic, medicinal, and analytical chemistry, his research focuses on developing anti-cancer, anti-diabetic, and anti-Alzheimer's agents. Dr. Patel has authored 69 publications in prominent journals, co-authored multiple book chapters, and is a patent holder. I request Dr. Patel to share his opening remarks with the presenters.
Am I audible? Others?
So,
Adesh?
yes, you're audible.
Okay, so thanks, Mr. Adesh, for the welcoming. Uh, Welcome to all participants for this 10th International Conference on ICT for Sustainable Development, organized by GR Foundation and publication partner is Spiritual Nature. As nowadays, sustainable goal development, if you have heard, in that there are many parameter is included. So when we are doing any work, it has to be aligned with the sustainable goal or development goal. Okay, and whatever we are doing in using AI in drug development and anything we are doing in the healthcare, definitely it will uh, directly or indirectly correlate with the sustainable development, which align with the our goal of the world. Okay, so I hope you are enjoying the all the session. Uh, is will be organized and already done in the yesterday. And best of luck. We will start the session. Adesh.
Yes, sir. Thank you, sir. So, we'll be starting with the presentations. And our first presentation is the paper title, A Comparative Analysis of ETF Performance Using Machine Learning Algorithms and Traditional Models. The paper will be presented by V.S. Ashwin.
Hello, am I audible?
Yes, sir, you're audible.
Okay, let me share my screen.
Sure.
Is the screen visible?
No, sir. Dr. Patel, is it visible to you?
Okay, is it visible now?
Yeah,
Now it is visible.
now it is visible,
Okay,
right? Yeah, sure.
okay. Good afternoon, everyone. I am here to present our paper on the title A Comparative Analysis of ETF Performance Using Machine Learning Algorithm and Traditional Models. Our paper ID is 679 and authors are Ajay J, Kavita R, Danya M, and myself, V.S. Ashwin. We are from Amrita School of Business, Amrita Vishwavidyapitham, Cochin. Moving on to the introduction, exchange traded fund or ETF have become increasingly popular in both global and Indian market. We can see the key features of this ETF. Because of this, the investors are more interested in investing in ETF. I have shared a graph which shows the trading volume of ETF from the year 2016 to 2024. We can see a rapid growth because ETF are the basket of securities like stock, bonds, commodities, etc., and which have the key features like diversification, liquidity, low expense ratio, no lock-in period, and small investment unit, which make the investors more interested in to invest in the ETF. Next is the research objective. Our research objective is to analyze and forecast ETF performance across 7 major sectors, which is pharmaceutical, FMCG, banking, IT, infrastructure, healthcare, and consumption. And to evaluate the model performance using key matrices, we are using R square, MAE, and MSE. And also to identify which forecasting model provide the highest prediction accuracy for each sector. Okay, going through the literature review, we can see that many of the people have done the research using machine learning algorithm and traditional modeling algorithm, but they have not done in the Indian context. As we know, Indian context have different criterias, and this studies reveals the potential of machine learning models, but also highlights the needs for region-specific research, especially in Indian market. Okay, going through the methodology, we have done a descriptive approach as a research design, and the data is secondary data, which is collected from investing.com. The period of the data is 3 years data we have collected from 2021 to 2024, and the frequency of data is daily. As I already mentioned, the sectors that we have taken is that pharmaceutical, fast-moving consumer goods, banking, information technology, infrastructure, and healthcare. The predictive algorithms are ARIMA model and hot windows, which is the traditional model, and the random foresting and support vector machine, which is the machine learning algorithm. The evaluation matrices are R square, MAE, and MSE. These are the analysis part and the result. Here we can see the comparison of MAE value across different sectors. Here we have mentioned the different sectors, and the graph shows the models, the SVM, ARIMA, random foresting, and hot wheelers. In the case of MAE or mean absolute error, lower value means it is more accurate, and random foresting is showing more lower values. In MSC also, in the case of MSC also, the mean squared error is lower. The value is lower. It means the less deviation. And in this case also, random foresting is showing less. And in the case of R squares, coefficient of determination, higher the value, better the fit. And here we can see. Okay, excuse me. Hello, is it visible? Hello. Okay. Okay, higher the value, it's better fit. And here also we can see random foresting is performing better. Okay, our key findings are random forest was the best performing model across all sectors with highest R square and lowest error values. Traditional models were useful in stable sectors but failed in dynamic sector, and SVM showed potential but lacked the accuracy and stability of random foresting. And Nippon India ETF consumption emerged as the most predictable ETF. When we move on to the conclusion, our research concludes that random forest is the most reliable and accurate model for predicting ETF prices in the Indian market. It outperforms traditional model, even SVM, by effectively capturing complex and non-linear patterns, which are common in volatile sector. As ETF grows in popularity and market becomes more complex, machine learning models like random foresting will be vital for investing, forecasting, and portfolio optimization. That's all. Thank you.
Hello,
Hello.
am I audible, Ashwin?
Yes, yes, yes. Yes, sir.
Oh, Mr. Ashwin, you have work on the machine learning algorithm ATA. Yeah?
Yes.
Hello,
Hello. Yes, sir. Hello, am I audible?
hello. So can you tell me, see, there are many algorithm. Yes, you are audible. There are many algorithm-based ETF related to ETF is there in the market also. So how your concept is somewhat superior or comparable over other algorithm? Because there are many DNA-based other algorithm also available in the market. So can you tell me the correlation of your concept and the available concept?
Okay, sir. Hello, am I audible?
Am I audible?
Okay.
And
When
you
it
are
comes,
audible. Oh,
okay. Usually, what happens to the other model is that we have taken the traditional model also. When it comes to non-linear data, it is difficult to get the answers. As I already told in the Hot Wheelers and ARIMA model, if the data is non-linear or data is not stable, it is difficult to get the accuracy. They are not giving the answer in an accurate manner. But here we have taken seven uh, sectors which are stable. There are stable like uh, pharmaceutical and healthcare are stable, and the other sectors are non-stable. Even though we have taken different sectors, the random foresting has shown a better accuracy.
okay. Is it this is your progress of work? I think it is not still end. Okay, na?
Okay, sir.
Hello.
Hello. Sir,
What will be your future plan of this algorithm?
we
Hello.
have we have limited our study due to some time constraints, but we would like to explore more and go to more uh, algorithms and research it far in the future.
Okay. Okay. Thank you.
Okay, thank you, sir.
Thank you, sir. We'll be moving towards our next presentation. And the next paper to be presented is a novel deep transfer learning model for IoT botnet attack identification. The paper will be presented by S. Prince Samuel. Are the author or any of the co-authors present in the meeting? Okay, so there is no response. We'll move towards the next paper then. The next paper to be presented is Advancing Educational Inclusion, Integrating Indian Sign Language with Spoken Language through LSTM Neural Networks. The paper will be presented by Arya Gowde.
Good afternoon, sir. Am I audible?
Yes, you're audible.
Yeah. Is the screen visible?
Yeah, the screen is visible.
So we'll begin it.
Sure.
Myself, Arya Gowde, and we have worked on a paper advancing education inclusion, integrating Indian Sign Language with spoken language through LSTM neural networks. The author's name for this paper is Aaron Mendonca, Arya, Nikki, Nilay, Rohit, and our professor Nikita Raichadda. We have been affiliated with SPKM, Dwarkadas Zivandar Sangvi College of Engineering from Mumbai. So, what sparked the idea? One evening I was at a
Excuse
restaurant
me, ma'am.
and
Yeah,
Yes, sir.
sorry to interrupt. I just wanted to mention that if you are changing the slides, it's not visible. It's like stuck on the very first slide, the presentation.
Uh, oh yeah, I am sharing it. Is it not visible now also?
Like, can you just click on the slideshow and no, yeah, it's
Okay.
moving, but not in the slideshow view.
Yeah. Not able.
Some network issues there.
I'll join back again if that's okay.
Okay, sure, sure. Just let me
Thank
know
you.
when you have joined back and resolve the issue in the chat box.
Yeah, sure. Thank you, sir.
Yeah. Okay. Then we'll be moving towards our next presentation. The next paper to be presented is on Agrotech Navigator, ML model for projecting demand as well as supply for agricultural commodities. The paper will be presented by Mohit Mate. Mr. Mohit or any of the co-authors of the paper, are they in the meeting?
Yes, we are. Pratik
Yes, sir.
Pratik will.
Am I audible, sir?
Yeah, you're audible.
Sir, sorry to interrupt.
Yes.
Sir, just can I know when will be 745 ID number will we have presentation like all of us having some issues. So will it be possible to complete before 1:30 for us 7:45?
Sorry, I didn't get your question. Do you want to conclude your presentation before 1:30?
Yes. Will it be possible?
Let me just check. I'll just ping you in the chat box. Uh,
Sure. I already pinged you in chat box. Please confirm it.
I think I have messaged you in the private chat box. Please do
Okay.
check it. Yeah.
Okay.
We'll move with our presentations. Yes, Mr. Pratik, you may proceed with your presentation.
Am I audible, sir?
Yes, you're audible.
Hello.
I said you're audible.
Let me share my screen.
Yeah.
Is it visible?
Yes, it is visible.
So let us start with hello everyone. Hello everyone. Myself Pratik Dagavkar. I will start my presentation. As you know, our topic is Agrotech Navigator, which is related to agriculture. So let us start with introduction. Our agriculture continues to be backbone of India's socio-economic structure. It employs over 50% of the workforce and contributes around 20.2% to India's GDP as per 2021. However, its GDP contribution is declining. A significant percentage of rural population, about 59%, depend on agriculture, which is vulnerable to unpredictable weather and inefficient planning. The background to our paper reveals that the Indian farmer lacks the technological resources to plant crop based on weather and market dynamics. The result in mismatches between production and market demand, impacting farmer income. Now, our motivation stems from the and accurate demand supply forecast which can boost income and reduce losses for farmers. Integrating machine learning offers a practical way forward. The problem we are addressing involves building a predictable system that estimates both crop supply and demand while incorporating real-time weather data. The system is designed to help farmers make more profitable and risk-reducing decisions. To formulate the problem, farmers currently rely on institution and outdated methods, unable to align with changing weather and market conditions. Our system use ML model like random forest and navy bias to support precise prediction and planning. These feature selection techniques enhance model performance, focusing on key variables like rainfall, temperature, and other necessary nutrients. And mm, our related works incorporate the other technical um, other technical aspects such as integration of IoT, GPS, and remote sensing which improves farming through real-time monitoring. Our approach advances prior efforts by merging ML and machine learning analytics to support real-time and data-driven decisions. Our objective is to build a smart predictive system that helps farmers select the best crop based on market needs and environmental conditions. We aim to minimize crop surplus or scarcity and provide actionable insights that align with market demands. Now let us dive into our system architecture. As you can see, the system takes in crop related text queries and through a front-end web interface. This query go through several layers, such as you can see from input using adapter for pre-processing, identifying location, analyzing the best type of farming, and machine learning algorithm will predict the required crop which are going to be shown into the output. Now this query go through several layers, data processing, analysis via trained ML model, and then logical comparison using conversational data sets. The system provide output in both textual and chart form to help farmers to visualize their decision. In terms of algorithm, we collected and cleaned agricultural data set covering rainfall, temperature, soil nutrient, and crop yields. These were fed into Navy and random forest model to predict crop type and yield respectively. This is the whole steps of the algorithm we have discussed in last slide. Now the in term of the front-end web interface is solely built to be user friendly. It allows farmer to submit queries and receive near instant feedback in a simple and accessible format. The proposed system integrate all of these features and optimize for Maharashtra itself using hello, region specific data. Key feature include now this key feature mm, include high accuracy about to 99.39 for crop prediction and R square analysis equal to 0.96 for yield. Effective pre-processing and seamless integration for multiple data sets. Our diagrams, our architecture is shows how data flow and how the system responds. Now, our system has shown extremely promising result of crop prediction accuracy of uh, 99.3 and about a R square score of 0.96 in yield estimation. This figure demonstrates the model's potential in transforming traditional agriculture into a data-driven practices. So, in these are the some screenshots of our projects. Now, in conclusion, I would like to share Agrotech Navigator is a scalable smart farming solution designed to address real-world agricultural challenges. It reduces risk, enhances profitability, and align crop planning with dynamic market and weather trends. However, we also identify several limitations. First, the cost of adopting such advanced technology may be too high for small-scale farmers. And second might be inconsistent internet connectivity and digital illiteracy in rural areas may hinder implementation. Lastly, environmental unpredictability continues to challenge predictive accuracy. Looking forward, we see enormous potential to enhance enhance our system. Adding sensor-based input like soil moisture will increase precision. We plan to expand this model to include our states and possible countries. And we are thinking to launch a mobile app with local language support would vastly improve accessibility, predicting future crop prices, and optimize fertilizer watering schedules and additional possibilities. Now, talking about future scope, as we discussed earlier, adding sensor-based data like soil moisture and
Excuse me, sir.
temperature improves.
Uh,
Yeah,
just a quiet reminder, you have to conclude your presentation in 1 minute.
already concluded. Now, if there is any questions regarding it, so I would like to share this to my friend Mohit.
Okay, Mr. Pratik.
Yeah, sir.
Uh, this model which you are discussing, okay, in that you apply decision tree and support vector machine, okay, SVM, correct? Hello?
Yeah, sir. Random forest and decision tree.
You decision tree you apply. So there are many different good machine learning algorithm are there. So have you tried any other algorithm or you directly jump to this decision tree and SVM?
No, sir. No, sir. We have tried earlier multiple models.
Mhm.
As let me show the. This is the chart for other whatever the result given by other model. This is the 10 years neighbor random forest navy Bayes logistic regression, and you can see the random forest and navy Bayes give multiple more better result than other models. As we have get these points because of we have read multiple
Okay,
related papers.
got your point. Done. Now, what is your primary data set source? Means you have taken the government reports or any other price-based studies data set have you taken or directly you prepare your the response? What type of data set you use for these algorithm developments?
Sir, basically we have used multiple data sets and we have integrated to form a using Python pandas library to form a single database which could help us in this prediction and talking about the data set and key features we have used which have been taken from multiple government sources such as Kisan Crop and as one of the famous data set provider Kaggle, we have taken that for Maharashtra specific crop yield and which have multiple, I think, more than 12,000 records, which and some of the key factors includes these are the key factors. Let me give 1 minute.
Okay, got your point. You have
These are
taken
the
care
key
from
factors
Kaggle.
we have included. These are the
Okay,
key features
Kaggle
we
you
have
have
included in
taken.
our data.
So
Yeah.
how your model will be adaptable for different crop and age climate zone because see different state having different climate zone and different crop system. So is it possible for the other state and entire the country or some specific western region, north region you are targeting like that?
Yes, sir. We primarily we focuses on our Maharashtra related some of the districts such
Okay,
as Nanded, Latur, and Amravati, and we are
okay,
trying to expand multiple districts, and we are collecting the data over there. But for initial purpose, we have taken these four districts as a base point primarily.
okay. I understand. Only one suggestion from my side. If you are extend this your project, you can take the
Yes, sir.
mandi price also from other state. You can take from Gujarat. They are
Yeah.
ready to give you this mandi price and there are crop reports and everything they have. And if you will mail
Okay.
to the state, and they are ready to give because it will be helpful to the farmer for the it's very good actual concept nowadays. If it is feasible practically, then this can be tie up with the government also. But so many works has to be done before the
Yes, sir.
optimization of your model. Okay, so continue your work. Nice work. Okay,
Thank you, sir.
good.
Thank you, sir.
Thank you, sir. We'll be moving towards our next presentation. The next paper to be presented is the paper title Exploring Emerging Trends and Market Potential of Barrier Coating Chemicals in Sustainable Paper Packaging. The paper will be presented by Vanishri Pavalkar. Any of the authors present in the meeting? Okay, no response. So we'll be moving towards our next presentation. The next paper to be presented will be presented by Archita Bhattacharya. The paper title is FBCA IOMT, a federated binary contrastive autoencoder framework for anomaly detection.
Sir, am I audible?
Yes, ma'am, you're audible.
Okay, so I'm just sharing my screen. Sir, I guess it's visible.
Yes, ma'am, your screen is visible.
Okay, just a minute. So, a very good afternoon to one and all present here. Myself, Archita Bhattacharya, and we three of us worked on this paper, a federated binary contrastive autoencoder framework for anomaly detection. With me, another my junior, Ayan Bhomik, worked under my supervisor, Dr. Minal Kanti Debbarma. So these are the outlines. And about IOMT. So IOMT is a specialized branch of IoT in healthcare, where smart devices like wearables, sensors, and monitors collect real-time data. So here in this paper, our task is to identify the abnormal behavior, or we can say deviated from the normal behavior, like cyber attacks, all these things. So the main goal is to secure the privacy issues and data anomalies. So under the guidance of my supervisor, we have achieved 94.6% accuracy, 92.8% F1 score using autoencoder based detection. So here is the architecture of the diagram. Like we have first layer is IOMP device layer, where it collects the real-time physiological data, then local processing layer, then federated aggregation layer, then anomaly detection and interference layer, then evaluation and visualization layer. Then coming to what is binary contrastive autoencoder. Basically, it is a hybrid model where we have used two models, that is autoencoder and binary classifier. Autoencoder is for unsupervised feature extraction, and binary classifier is for supervised classification, where we means differentiated normal versus anomaly behaviors. Then here are some formulas where we have used to identify the logics. Then here is the framework, like key clients with local data set, then all these things. Then we have used 3 data set, which we have taken the data set from Kaggle only, HAR, and network intrusion and IoT attacks. Then here is the data pre-processing, where we have done missing value imputation, then Z-score standardization, label encoding, and optimal Gaussian noise injection. Then here are the feature engineering, correlation-based filtering, then variance thresholding, PCA, and encoder. Then here are the evaluation metrics, like for hours, it is giving 94.6, then 93.2, precision and recall is 92.5, and F1 is 92.8. Here are the diagrams of loss histogram, TSNE, and anomaly score. Then to conclude this, Since the area is the healthcare section is upgrading day by day, so it is main motive of our to secure it properly, to give the privacy, and so that poorest of the poor can avail these opportunities. And since I just completed my MTech and my future goal is to do PhD, so I am just working upon it, how to implement these in the real time scenario. So future scopes are all these things: adapting thresholding for anomaly scores, optimization of communication efficiency, robustness against adversarial attacks, and real-time deployment on the edge medical devices. Here are some references. Thank you. If there is any question, sir, please ask. I'll try my best to give you the required answer.
Okay. Nice topic. Miss Archita.
Yes,
Okay.
sir.
Am I audible?
Yes, sir, properly audible.
Okay, so few things I would like to clear, I would like to ask. So, have you tried your model in the noisy condition for robustness study, assessment of robustness study, or simply your normal condition you try?
Sir, in the normal condition, actually, like I have just, sir, am I audible? Hello?
Yes, you are audible.
Yeah, sir.
What
So
type of
just
normal condition means?
just I have taken the models from Kaggle, sorry, data sets from the Kaggle, and I have implemented, not in the real time scenario. So it is my goal to test in the normal time, in the real time scenario.
Okay, real time you will do in PhD if I'm not wrong. Okay,
Yes, sir. Real time in the
so
PhD, I'll be doing.
can you tell me what is PCA?
The principal
Hmm? Hello?
component. Hello.
Okay,
So
so what is
just now I
correlation?
can. So PCA is the principal component analysis, and correlation is. Hello, sir.
Network issue is there on your side.
Yes, sir. And hello, sir. Correlation is a statistic measure
Am I
that
audible?
expresses.
Hello?
Hello, sir.
How you ensure the privacy, how you ensure your privacy and security in your model? You have taken the data set, but in output correlation may be there in your conclusion or in your output results.
With the help of the mathematics, I have done. So correlation is basically the statistical measures that will express in two variables, like they are linearly related. So with the help of the formulas, I have used it.
Oh, okay, thank you.
Thank you, sir. Thank you, ma'am. We'll proceed with our next presentation. The next paper will be presented by Arya Gaude. The paper title is Advancing Educational Inclusion, Integrating Indian Sign Language with Spoken Language through LSTM Neural Networks. Author or any of the co-authors in the meeting, please respond.
Hello, sir. Am I audible?
Yeah, you're audible.
Yeah, I'm trying to screen share it. Is
Can you just try it out now?
yeah,
Maybe
sure.
I was also sharing and that might have caused an issue.
Is it visible now?
Yes, now it's visible.
Sure.
You may proceed.
Sir, our paper title is Advancing Educational Inclusion, Integrating Indian Sign Language with Spoken Language through LSTM Neural Networks. The authors of this paper are Aaron, Arya, Nikki, Nilep, Rohit, and our professor Nikita Raichadda. We are affiliated with SVKM's Bharkara's Jivanlal Sangvi College of Engineering College, Mumbai. So what sparked the idea? While dining at a restaurant, I observed a woman facing challenges while communicating with the waiter. She was deaf and mute and had to wait for a relative to place even small requests like for for water, for spoon. So this incident highlighted and made us think about these scenarios where people of the deaf and mute community find it difficult to communicate with public like us. And it made me realize that we never learned their language and it was never their fault, it was always our fault. So that motivated us to develop this product and finally the research behind it. So introduction here, approximately 18 people in India are deaf and 4.5 people use ISL to communicate. And however, ISL is not widely communicated by the general population. These gaps lead to a barrier for the community of the deaf and mute in education, in employment, in healthcare, and in daily life as well. There is a lack of a real-time tool which can help them for the dynamic gestures to be detected and help them to communicate with us properly. So while learning about this concept, we read few papers and the literature review for this is 16 papers. I have listed all of them here. So here are the 5 papers, the next 5 papers, and next 5 papers. The common research gap that we found was most of these papers were developed on the American Sign Language, and there were very few papers which actually had worked on Indian Sign Language. And those which had worked on ISL had only static gestures, which like the dynamic gestures, the real-time gestures were not included in it. Language limitation was a problem as well. Like most of the papers or the research which worked on couldn't translate it to another languages. And ISL is something like which is similar in even in Maharashtra, even in Gujarat, even in Goa, even in Karnataka, all over India, the ISL remains same. But people who are learning this language is very few, maybe because of the education barrier. And since there is no faculty to communicate, to teach this community. And yeah, which everything leads to a low real world robustness tool. So while finding this research gap, we came up with the following objectives. That is to develop a real-time ISL gesture, then to utilize and model. So while reading this paper, we found out that LSTM was working well on static gestures. So we decided to try working LSTM on the dynamic gestures as well. While creating this, as I said earlier, the data set or ASL was widely used. ISL dataset was very limited. Hence, we had to curate the dataset from the scratch and to convert a multilingual text to speech and to promote inclusivity through user-centric tool. So I'll show you the system architecture. So let's start with the first part, that is a blue color lines we can follow. Input is the gesture and output is the text. So for this, what we did is the inputs, like the gesture was recorded. It had some coordinates, which the key points were extracted using the media pipe. These coordinates were passed to LSTM models because of the change in the sequence. The prediction was made using the LSTM model and that word was found. Many words for individual gestures, like one sign has many words like hello, hi, and everything is same. So forming such sentences was important. So that was, sorry. So that was done at the second LLM part. If we move on to the second, that is the red dotted lines we follow, that is the second part, that is text to gesture. The text sentence was broken down into tokens. These tokens were founded in a lemma, like in a corpus, matching those corpus in the existing directory and combining those videos to one particular sentence was done. So dataset overview, self-curated from 5 participants. 55 ISL gestures, 33 to 22 static gestures were captured. These gestures were captured by all of us, and for curating this data set, we had taken guidance of an ISL official ISL translator. This is the model architecture. We used 3 LSTM models, then followed by 3 dense layers, and the output was then the activation function used at the output was softmax because we wanted to predict one particular class.
Excuse me, ma'am.
Yeah,
Sorry to interrupt. I just wanted to mention you have 2 minutes of time left to conclude your presentation.
sure. So results and evaluation is static and dynamic gestures are all these are using the static gestures which had 89, 94, and few had 99% accuracy as well. Our model created a training accuracy of 97.59%, validation accuracy 90.28%, and F1 and precision 0.99. There's a quick demo if possible. Or else we can move forward. I'll show you the demo at the first. Future scope is to make this model utilized in currently it is working on website. We can have it on mobile nets as well, and you incorporating more words. Since we have also limited to 55 currently, we can have more words data. And conclusion is developed a real-time ISL translation system using deep learning, that is the LSTM model, achieve significant improvement in dynamic gesture, that is reaching accuracy of 97%, inclusivity, scalability, and multilingual output was obtained. Thank you. I'll just show you the video from your. I'm not able to move forward.
Okay, no problem. Let's a new concept. Okay, Mr. Arya,
Yes, sir.
am I audible?
Yeah.
Very nice topic. And nowadays we needed this type of thing. Mm, And you are in right track, actually. So I like your concept. Now,
Thank
just one question. Can you go to that result and evaluation slide where you apply hybrid model? The
Yeah, sure.
accuracy is mentioned.
This one?
Yes, yes.
Yes.
So here you apply hybrid with the CNN, with the basic neural and RL.
No,
Okay.
sorry. This is the previous models. So paper titles are here. And the bottom part is our predictions, our outputs.
So have you tried hybrid in CNN with your LSTM and RNN with your LSTM, or a hybrid model are you following, or
No, we actually used only LSTM because, as I said, LSTM was working well on
only?
static because of one of the previous paper.
Oh, no problem. I
Yeah.
understand. Okay, but just I'm asking because few paper I read 2 months ago that they also use the hybrid model in your LSP, what you are discussing. Plus, what is the size of your data set and what type of data set you have?
So we had 55 words. Each word was like we
Okay.
created, recorded it 30 times and broken it down into 30 frames. So we had all the angles. Like we created, I remember it that 5 from this angle, 5 from the same word was created 30 times, dividing it to 10, 10, 10, 10, 10 times. So we are getting different angles for the same word, and then it was in the form of video. Then we converted into we just found out the coordinates, and those coordinates were then saved into .npy file.
Okay, thank you. Nice one.
Yeah, thank you.
So thank you, sir. Thank you, ma'am. We'll be moving towards our next presentation. The next paper will be presented by Aditya Thakur, who will be presenting his paper on handwriting digit recognition using CNN. Mr. Aditya or any of the co-author? Okay, yeah.
Am I audible, sir?
Yes, you're audible.
Give me a second. I'm just going to share my PPT.
Sure.
Is it visible?
Yes, sir, it's visible.
So, good afternoon, all. I am Aditya Thakur, presenting alongside my team from Chandigarh University on the research paper named Handwritten Digit Recognition using CNN versus Efficient Net V2. So, handwritten recognition, as we know, it is crucial across the industries like banking for check processing, post offices for short mailing, and especially in OCR systems for digitizing the records. But the big challenge in the variation in handwriting styles, noise in images, and limited resources for real-time use. Uh, Basically, our goal is to address these challenges with modern machine learning techniques. So, we wanted to compare two powerful neural networks, a traditional CNN and a modern efficient V2, to see which is better suited for the recognizing handwritten digits and symbols. We have focused on three key goals, which are comparing performance, evaluating the generalization across the datasets, and suggesting the real-world use cases for the each model. So, at the datasets overview, we have used two main datasets, which includes EMNSAT dataset and HAS-YV2 dataset, in which EMNSAT dataset includes 280,000 training images and 40,000 test images, includes only digits and letters across in 28 by 28 pixels of grayscale. On the other hand, we have HAS-YV2 dataset, which is a bit tougher dataset than EMNSAT, which includes 168,000 images across with 369 different symbol classes in 32 by 32 pixels of format. Uh, Before training, we cleaned and standardized the images, which includes the grayscale conversion, normalization of the pixel values, and resizing to uniform dimensions. Data augmentation like flips, rotations, and noise, these help the models generalize better and handwriting variations. So at here we use two models, a basic which is CNN, made of layers that learn edges, curves, then combines them to recognize the digits. It's simple, fast, and accurate for the structured data. And on the other hand, it's efficient at V2, which is mainly by the Google, a newer model by Google that has specially blocks like SC to improve efficiency and accuracy, but it's more complex and needs more fine tuning. Each has unique strengths depending on the task and values. For the training setup, we trained both model using PyTorch on Google Lab. We used Adam optimizer for the both and learning rate scheduler. We made 20 epochs of each of batch size of 64. Training environment was the same to ensure a fair comparison between the both of the models. Talking about our results are very clear. The CNN achieved 99.65% of the text accuracy. It learned quickly and performed extremely well on the structured digits and letters, whereas efficient net V2 only reached about 47.55% of possibly due to being over designed uh, for this simple task and lacking of fine tuning. This shows that sometimes a simpler model is actually better. So here are some key takeaways. CNN work great job for the simple and clean data sets, whereas efficient net V2, while it is a powerful but needs more data and tuning to show its strength. And HAS5V2 is more complex and could beneficial for efficient net V2's architecture. Through those results, our focus here. Our conclusions are using simple CNNs for tasks like digit recognition, where data is structured. We can use efficient NetV2 for messy or complex symbols if you can afford the time and compute. This research help us to guide real-world OCR systems design, balancing accuracy with efficiency depending upon the scenario. Thank you. That's all from my side.
Okay, am I audible? Aditya,
Yes, sir.
nice work. UCNN, okay, very good actually. Algorithm model and accuracy 99%. Correct?
Yes.
Okay. Now data set you use. Well, means what type of data set? Have you tried different handwriting or normal handwriting? Like Urdu Devangiri, any other
Sir,
handwriting?
got it, sir. In the both datasets, which is EMNSIT and HAS by V2, there are handwritten structures or letters or symbols along with their original structure, which can be easily understood by our system. So at first, it our system checks the handwritten structure and then compare to its original value to find its accuracy. So in this way,
Okay, so it can be applicable to all.
yes, sir.
That means
Yes, sir.
all handwriting.
Yes, sir.
Okay, and is it practically in real world? Is it possible like in banking service and postal service we need this type of things? So is it possible practically or
So
you not try till?
So basically, practically it can be possible because it depends on a data set that what kind of data set we are using and for how much time, how well we are training to our model to perform in our industry. But yes, we can say it is possible for practical thing, but we have to take some uh, precautions like noise. There should not be any kind of noise while recognizing the digits or other kind of precautions for that.
Means noisy actually when you do practically you need to apply the wrong sign also.
Yes, sir. It may lead.
Okay, so your so it will easy to get your increase your accuracy plus if any error will occur during the conversion, so it may helpful to you also.
Yes, sir.
Okay, nice. Otherwise, very nice concept you discussed. Good, continue. Thank you.
Thank you, sir.
Thank you, sir. Now moving towards next paper. The next paper to be presented is hedonic and utilitarian motivations to use AI-powered parenting apps among young Indian parents, a pilot study which will be presented by Anupama K.
Hi, sir. I'll be sharing my screen right now.
Sure, ma'am.
Please let me know if it's visible.
Yes, ma'am, the screen is visible. You may proceed.
Okay, thank you. Hi, all. Good afternoon, everyone. I'm Anupama, a research scholar at Amrita Vishwavidyabedam, Coimbatore. The topic of my pilot study is hedonic and utilitarian motivations to use AI-powered parenting applications among young Indian parents. We all know that parenthood it is a period of dramatic physical, social and psychological adjustments that are filled with joy and worry for many of the parents. Especially for the first time parents, it may be particularly challenged as they may feel unprepared to care for their infants. They may also rely upon internet and mobile applications for support in handling their day-to-day parenting situations. Due to the growing popularity of parenting apps among the tech savvy parents, countries like China and India have witnessed a significant surge in smartphone adoption. According to the Data Analytics Guru's report in 2024, the parenting apps market is projected to grow by USD 474.72 million at a CAGR, that is compound annual growth rate, of 11.69% in the next 6 years. The increasing acceptance of smartphones and digital technologies in India has transformed how women handle their maternity and parenting roles. Milo, which is an established maternity and parenting service, undertook a survey of over 4,600 women in India to better comprehend how technology affects Indian women's experience with parenthood, childcare, and access to the healthcare. Parenting and AI technology have a symbiotic relationship, which can be integrated for personalization and societal benefits. The research also points towards parental attitudes being affected by mediated technologies such as AI, while AI research culture is drawn on the experience and theory related to the parenting. Nowadays, the new age parents rely completely on the recommendations from the apps, which limits their parenting journey just in the digital realm, which is actually a negative impact. Petzlori et al. In 2024 identified different motivations to use AI powered parenting applications such as emotional release, mastering new skills, personalized and reliable feedback, reflect and grow, educational content and resources, stay on track with encouragement, safe space for dialogue, personalized support, situational feedback, simulation and insight generation, goal setting mechanisms, and to provide integrated support with the help of AI delivery mechanisms such as chatbot, voice assistant, wearables, intelligent notebook, web based parenting platform, IoT, virtual and humanoid coach, personal assistive robot, and sensor based tracking and smartphone application. According to Ryan and Daisy in 2017, the self determination theory qualifies consumer behavior by hedonic or intrinsic motivation, such as pursuing pleasure and satisfaction, or utilitarian or extrinsic motivation to attain resources and to reduce risk. The concept of mothering or parenting in the contemporary context can be framed within the paradigm of a technology of transformation, which is related to the word of machine phenomenon described in the study of Longini et al. In 2020. The studies majorly centered upon the app users, including pregnancy and parenting community. However, the insight of the young category parents is similarly a significant metric. The Indian context was also least observed in general, and also the impact of AI mediated parenting application were also less discussed. In-depth study on types of AI delivery mechanisms available in parenting apps and the user experience among young Indian parents were also scarce. The influence of motivations, or the HCI, that is human computer interaction features for parenting support across the needs and technology delivery mechanisms were also not studied in detail. The study explores the awareness and use of AI intervention in parenting apps and the motivations of young parents to use them. Firstly, to find the levels of motivations to use AI powered parenting apps among young Indian parents. Second, to divide young Indian parents into clusters based on their levels of motivations to use AI powered parenting apps. Third, to find the potential differences in young Indian parents' perceptions of motivations to use the app and by categorizing the extent of support they receive from their family and parenting applications. Quantitative survey method was used to understand the motivations to use the parenting apps and as well as to exemplify users into types based on their motivation patterns. And an online survey method was used where the questionnaire was prepared using Google Form and snowball sampling was used to identify the samples and to get a maximum reach. 120 realized samples were obtained and the questionnaire had three parts. First, assessing the demographic traits of respondents. Second, relating to the patterns of use of parenting applications. And third, relating to their motivations to use the app based on the scale questions drawn from the previous study. Respondents were largely drawn from metro cities and municipalities across South India, predominantly female who are between 30 to 35 years and who belong to highly educated category with a family income of up to 4 lakh per annum. Most of the parents were to the children below 1 year of age, and majority of the respondents were recent users with using the apps in the last 1 year. Respondents had a high awareness of AI parenting apps, and a large percentage of respondents agreed to the symbiotic relationship between the apps and family when it comes to the parental care and support. Among the AI features in the app, chatbot scored at a maximum, and dimension reduction, that is principal component analysis, using Opplement rotation of the items related to the motivations to use the AI-powered parental apps resulted in two components, that is utilitarian and hedonic motivations. The
Excuse
Z-score,
me,
that
ma'am.
is, yes, yes,
Yeah,
sir.
just wanted to remind you that you have 2 minutes of time left to conclude your presentation.
Okay, thank you for the reminder. Z-score, that is standard score for motivations to use, were analyzed using K-means cluster analysis, which resulted in the identification of four distinct clusters, that is unconscious user, beta user, self-fulfilling or functional user, and alpha user. So the K-means cluster analysis process involved standardizing the data or Z-scores, selecting the clustering algorithm, determining the number of clusters, running the K-means algorithm, and interpreting the and labeling the clusters. So the beta, which is the largest cluster, it is a positive and showed a positive and moderate engagement, and exploring emotions and personal triggers. And app, which has dedicated channels to express perspectives and concerns, showed the hedonic and utilitarian traits. And self-fulfilling user, they are the second largest cluster, who actively seek value to personal growth with emotional and practical benefits, exploring emotions and personal triggers, and gaining comprehensive understanding of parenting journey by the traits obtained. Unconscious user are the third largest user in different need, basic awareness, or motivation to explore AI features of parental app use. And the lowest scores are in utilitarian attributes such as provide integrated support and gain comprehensive understanding of parenting journey. Alpha users are the smallest group, which leverage a wide range of features for a balanced experience. So this group has a balanced mix of hedonic and utilitarian traits, which includes personalized and reliable feedback and provide personalized support. The current study attempted to explore Indian parents' motivations to engage with AI-driven transformative parenting apps. And the data analysis revealed that the presence of a larger cluster of beta users who typically displayed high hedonic and utilitarian motivation levels, along with small clusters of alpha users bearing the same traits. Scenarios for hedonic utilitarian motivations based on family or parental app support combination show that hedonic motivations of emotional release and input of daily routines and the utilitarian motivation of integrated support access while using the app is the highest in the presence of family support. So the family support has been proven to improve hedonic and utilitarian motivations to use AI-driven parenting apps by Indian new parents. This study found that the technology of transformation paradigm cannot act in vacuum but through in the family support-based parenting methods. Offering new evidence on parenting behaviors in digital ecosystems, aligning with the emerging discussions in cyber psychology and digital well-being, especially regarding AI's role in caregiving, is the academic implication of the study. And by aligning with motivational types, app managers can design personalized UX or UI or push notifications or AI-driven suggestions that increase long-term app engagement and loyalty will be the managerial implications. These are the references used for the presentation. Thank you.
Am I audible?
Hello. Yes, sir.
Nupuma, Miss Nupuma. Audible?
Yes, sir. Yes, sir. Yes, sir. You're
Okay,
audible.
nice topic. Nowadays, parents need this type of, services should be beneficial to parents also.
Yes, sir.
Some very, I would like to verify. You have taken Metro City, the beta,
Yes, sir.
the
Metro cities
whatever.
and
Uh,
municipalities. Yes, sir.
what about the other?
So especially there was a study conducted like an initial thought using the rural communities, but the reach of the awareness was seen less. So as
So,
to expand the
yes,
awareness, uh, sorry, sir. Hello.
I got your point, but
Yeah.
when you during the accuracy, model accuracy,
Mhm.
practically, if you want to apply, so you can try in each and every area of our country.
Yes,
If you
sir.
are trying South India, you can try each and every area of your South India region.
Yes, sir.
And what
So,
about the study you are using? Either it is
sorry,
qualitative,
sir. So it was a
see, what type
quantitative.
of study?
So it was a quantitative study as an
Means
initial research. So I am planning to expand the same using a mixed method, and to expand the reach, as you said, to reach the rural communities as well. So the metro villages, everything will be considered in the expanded study.
because nowadays they are using many good smart app also
Yes, sir. Yes.
in
Yes.
village area also they are using nowadays.
Yes.
So you can try. Other
Yes.
concept I like. The concept is good. Just you have to expand your data set because whatever data set you use, it is not that much very small data set. You can
Yes.
try. You can use more data set.
Yes,
So
sir.
practically accuracy and application you will get in the future.
Yes, sir.
Okay.
Definitely. I have
Nice.
already started
Very
for
good.
the work.
Continue.
Yes, sir. Thank you.
Okay. Thanks.
So thank you, sir. Thank you, ma'am.
Thank you.
Now we'll proceed with our presentations. The next presentation is on the paper title Offline Signature Verification Using Region-Based Geometric Feature Matching with Adaptive Similarity Scoring. The paper will be presented by Prabira Kumar Sethi.
Uh, Hello, am
Hello.
I audible?
Yes, sir, you are audible.
Yes, let me share my screen. Uh, is it visible, sir?
Yes, sir, the screen is visible.
Oh, okay. Okay. Good afternoon, everyone. Actually, our research paper is on offline signature verification using region-based geometric features matching with the adaptive similarity scoring. Our authors are Dr. Praveen Kumar Sethi sir, Sachin Sharma, Ajit Behera, Satyaprakash Parik, and I, Amdesh Riya. We are from Sambalpur University Institute of Information Technology, where department does ECA and CSE departments. Yes. Okay. Uh, what is our goal? Our goal is the signature verification is a key part. Actually, signature verification is a key part of authentication in the financial and legal systems. This research introduced a offline method that tracks signature by analyzing the shape and the structure of the signature. This process involves converting the signature to binary images. Orientation. Hello, am I audible, sir?
Yes, you are
Yes, sir, you
audible.
are audible.
Okay. Major axis and minor axis, orientation, convex area, Euler's number, and equivalent diameters, and utilize the adaptive similarity scoring and reboot the authentication. In this process, actually, we got 95% accuracy than others method, and the method is fast, accurate, and efficient. We do not need a large dataset to uh, convert to work on this model. Actually, the signature verification is commonly used in identification verification in banking and legal government systems and social awareness. Manual verification is time consuming and prone and errors makes it the essential to development the automation systems and detect the forging accurately. Older method like the pixel by pixel comparison and template matching are the unreliable as they are the sensitive to noise and scales and orientation changes. Modern system analyzes the structural and geometrical features such as area, perimeter, centroid, eccentricity, solidity, and major and minor axis and variety authenticity. And each of the research works on applying images processing, machine learning, and deep learning to improve the accuracy and reliability in signature verification systems. Actually, there are many related work on deep learning techniques of the signature verification. There is some first they introduced in 2020. That is Simon's network. Is a kind of neural network just use the multiple data sets for training these authentication systems, and then introduced in 2021 GLCM and PCA, KPCA with the CAN array neural networks, CAN array neighbors and Naviwire are accuracy of 82%. Then introduced in 2022 is CNN Alex net. It is also kind of this Simon network, or and its accuracy is greater than 85%. Then introduce the deep learnings offer the high accuracy, but it needs a large or of data set that is hard to actually use. Then the other description of one by one, first introduced in 2021 in AI signature verification, then 2020 in the CNN with the hybrid feature expression, and this accuracy is region is 85 to 95%, 4G are 85 to 89%. Then introduce GAN and hybrid models and signature verifications. This 1D conventional GAN am I audible, sir? Hello. Okay, limitation of the deep learning model. Actually, in the deep learning model, there it's used a vast amount of the level data and low power embedded systems, and it's a black box view. What's a black box view? It's there's a process where user don't know what the actual process. It's a abstract view to users, and user only can use this process, nothing to know the what is internally it's going. And then building and difference by the soft computational time comes and expert knowledge, then minimal computational region and simplicity. Are the some traditional method we introduce. Then what we introduce actually, wait a second. Our methodology is to we use MATLAB initially to recognize the signatures. Its accuracy is 95%. We got. This is the prepared. What is the pre-processing step in the adaptive, the thresholding and binarization and segmentation? The isolate the primary signature recognition in backgrounds. Actually, we are binarizing data. Then we create a MATLAB code where the MATLAB code is extract this binarization image format to the geometric pattern and morphological feature analyze. Then the signature is cross-checked for verification. uh, Actually, what we are doing in the past process, we are referring some of the referring signature of some of the test signature of the users. Then we do tests on the other signatures. Like in this process, we give this some signatures of a users. Then we give some different other signature to cross check the signature when it's we've got a 4G signature, it not match. And if got a correct signature, then it's match. It's works on the 95% accuracy format. Second. Then what's our algorithm actually? Our algorithm actually, we load a JPG or PNG or any kind of the image file. Then it's got binarize the data. Then it's process the data. Then extract the data. Then after the extraction, we compare the data with the previous recorded data sets. Then we got the similarity or dissimilarity in between. If the threshold, our threshold is greater than 95%, it's matches greater than 95%, then it is correct, or it is a real signature, or if not match, then it is a forgery signature. We use our testing environment in Matplotlib in 2004 Intel i-Core i7 and processing 64 GB and RAM. And in this process, actually, our experimental delivery 100% similarity, scoring the 66.7%.
Excuse me, sir. Sorry to interrupt. Just wanted to mention you have 2 minutes of time left to conclude your presentation.
Hello, am I audible, sir?
Yes, sir, you're
Okay.
audible. And as I mentioned priorly, you have 2 minutes of time left to conclude your presentation.
Okay. Okay. Sir. Actually, after the experimental result, the practical result test result is on the real world the validation is around 95% of similarity threshold, and the forgery are the 61 percentage, and 50 that is range is around 55% to 67%. We are average is 61%. The clear distribution between the genuine and the forged samples. It's these are the original signature are scoring 95%, then forgery are around 55 to 67%, and the unreliable, which are actually not the properly showing images. These are the unrelated images. As I seen saw you previously, then it's a comparison between the existing method and our method actually. This method, the technique and performance. In first, the method that Simon network, this is a kind of the neural networks, and then accuracy in uh, specified. Then GLCM with the PCA, with the ML classification, the accuracy with depend on the KNN 82%, then and then root first method is 81%, then navy bias 56%. And actually extra we added a region based geometric method which is better the accuracy is 95% and transparent and efficient. And the conclusion is that in our method it is support the offline verification systems, and it is a simplify method, and it use the geometric feature to after the signature, and transparency and interpretability, clear feature-based decision-making process, and crucial approach application in blanking and legal documents and the adaptive academic environment, computational efficiency and real-time capabilities like the fast processing time and efficient feature and extract expression enable the real-time biometric and authentication with the minimal latency. Thank you, sir. Uh, if you have some questions, you can ask. I will try to answer.
Nice. Now, but
Yes, sir. Yes, sir.
so the presentation is good. The topic is also good. But the whatever model you use, okay, you suggest that the 95% accuracy is there compared to existing the model.
Yes, sir.
Am I right?
Yes, sir.
Okay, so whatever see the result is giving from
Yes.
your model, whether it is genuine or forged, or is there any confidence level of matching is there, or only just simple result output like that maybe this signature is genuine or this signature is not
And no,
genuine
sir,
is
it's a
forged
genuine
like
level.
that.
Yes, sir. It's a genuine level matching. Actually, primarily, we have to give some of the real signature, the original signature of the users, and then we have to match with the forgery signature or the real signature of users. Like this image I am sharing you. That's Jyoti Kumari is sharing is real some of the pictures, and then we
What
try
about
with the yes. Then forgery, it detect the forgery or the
okay,
real.
what
So
about the
this parameter are we are using is
what about digital manipulated?
what's up? Hello.
What about digitally manipulated signature?
Okay.
What about
Okay.
the digitally manipulated signature?
No, we are it's a biometric signature. We are not digital like signature. These are the images of signature. Like we put a signature on a paper, like the
Okay.
yes. Not we cannot. We're not trying on that actually.
Okay. Okay. So
Okay.
you can you can try actually because nowadays there are sometimes after COVID, digital signature arise so many in many documents digital signature are required actually in academic institution also the PhD always normally nowadays in the online and hybrid mode. So nowadays digital signature manipulation is also arising. So you
Yes.
can explore in that area also because so many work already reported in this type of signature, but not that much work is there in the digitally manipulated signature.
Yes.
So that is very beneficial to your model. So you can, this is my
Yes.
suggestion, and it's up to you. Okay.
Yes.
Otherwise, very nice. If you are getting 95% accuracy, that is wonderful. Really.
Yes, sir. We are actually
Okay.
develop already a
So
Android app
continue your
for
work
this.
and look
Okay.
at it.
Okay, sir. Thank you.
Okay. Nice.
Okay, so thank you, sir. Now, moving further, we have our next presentation. Now, the next presentation will be presented by Atul Kumar, who will be presenting his paper on review on security schemes in modern IoT integrated cloud systems. Mr. Atul or any of his co-authors in the meeting? It seems not. Just give me a minute here. So next paper to be presented is a novel deep transfer learning model for IoT botnet attack identification to be presented by S. Prince Samuel. Authors or co-authors of this paper, are they present in the meeting? Okay. Uh, Moving further, lastly, do we have Vanasri Pavalkar who will be presenting a paper on exploring emerging trends and market potential of barrier coating chemicals in sustainable paper packaging? Any authors or co-authors of the paper present in the meeting? There seems to be no response. Ladies and gentlemen, please give me 2 minutes of time. Okay, so we come to the end of this session. And as we conclude the session, I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. Now, I hope this session was informative enough, and we, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting the digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team ICT4SD 2025. Now, lastly, I would like to thank our session chair, Dr. Ashish Patel, for chairing the session. So here's a token of appreciation on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence.
Thank you. Thank you, Rajesh, and your team and their foundation. Always the presentation, always very nice. You are selecting and just suggestion from my side is always like that. Please do not just stop this work. You have to go beyond the publication. Try to make it
Yes,
patent or commercialize it because nowadays AI in healthcare is booming. Now next 10 years will be AI. Okay. So the AI people can do anything. So just continue and try to make it practically.
Sure. Okay. So thank you, sir. Now, lastly, I just kindly request you all to switch on the camera for a quick snapshot of the virtual conference. All the authors and co-authors. Okay. Thank you all. Stay safe and take care.